This is the second half of 1.5 notes. This is all the calculator parts. And I am recording this a little bit different than I would normally because I have to have my calculator showing. So this video, typically when I do it this way, is a little bit laggy. So if it seems like my writing is taking forever to go, that's why. Okay, so we should have done this stuff yesterday. I'm recording this ahead of time, so we're actually doing this in class today, but you should have already done this. So homework, page 53, 4 through 10, the evens, 14, 16, 24. Okay, seems a little bit scary because it's a short homework assignment, which means that each problem is a lot to do. So there's that. Starting with the calculator part. Okay, yesterday we should have hopefully talked about a least squares regression line, or a line of best fit. If I don't already have this written in here, line of best fit, and then you have something called a correlation coefficient, which is an R value, and your calculator will spit out an R value. I'll show you how to get that. Okay, to get that R value, and that R value will be a number between -1 and 1. Okay, the closer it is to -1, the stronger the linear relationship is. The closer it is to a +1, the stronger it is, but the closer it is to 0, it has a really weak relationship. Okay, so like if you go down to the very, very last page, it kind of shows you this. Okay, this right here, these dots are not completely on a straight line, but if I slap a line on there, they pretty well follow that straight line. This is going to be a correlation that's close to close to +1, so it might be like 0.98 or something like that. That might be really close. Okay, this one's a negative correlation, so it might be a -0.9. Okay, and the positive versus negative just has to do with the slope. So this one's sloping upward, this one's sloping downward, positive versus negative. This one has no correlation. If I were to try to draw a line, I would maybe try to draw it like here, because I'm hitting a couple of the points. So I would maybe say it's more positive than negative, but it would probably be like a positive 0.1 or something like that, right? Really, really close to 0, so no correlation. So that has to do with that R value, or that correlation coefficient. Okay, and I will show you on the calculator here quick how to get that R value to spit out. Okay, so first thing we're going to do is they give us a data set, and it says a circle can be circumscribed around a regular polygon, and the lengths of the radii of the circumscribed circles around the regular polygons whose sides have length of 1 unit are given as follows. Bleh. Whatever. We're just going to plug that stuff into our calculator and get it to draw a scatter plot for me. And then we're going to calculate some stuff and find a model that best fits and all that good stuff. So first thing that we're going to do is go onto our calculator. I'm going to click over here, and I'm going to go stat. Oh, got to turn it on. Okay, so you're on the main screen here, and again, anytime you're on a screen that you don't want to be in, you go second quit, right? Okay, here I'm going to go stat, and I'm going to enter in some data. So we go stat edit. Okay, and we've done this before. We did this on the first couple days of school where we entered in some data. So I'm going to put that off to the side over here if you forget. Step number 1, we go to stat, and then we hit enter, which is the edit button. Okay, stat edit, or just enter. Stat enter. Okay, and it takes us to this list. If I want to cancel out or get rid of the data in that list, I go up to L2 and I hit clear and I hit enter, and then I can go over to L1 and I hit clear and I hit enter. And all I want to do is take this table and I want to enter the data in from this table. Okay, so these are going to be my X's and these are going to be my Y's. Okay, and so I'm going to enter them into the table, and this takes a little while because I'm recording, so sorry. I enter in 3. Practice doing this also. 3, 4, 5, 6. If you need to pause the video, you sure can. 7, 8, and 9. Okay, so those are my numbers for my X's. Okay, now this is what takes a while. 0.577. Enter. 0.707. 851. Sorry, I have to talk out loud, otherwise I screw up. 1. I'm just going to enter 1. 1.152. Enter. 1.306. Enter, and 1.462. I'm entering all that data in. Okay, so make sure that your numbers match up for 1, and you entered all of them in. But then also, really quick, before we move on, go back through and make sure that you typed in every single one of these numbers correctly, because if you even missed like one place or switch two numbers around, your equation is not going to come out the same as mine, and you're going to be like, what the heck did I do? Okay, so there is that. I'm putting my x's in list 1 and my y's in list 2. So there's that, okay? Help each other if you need to. There's that. And then I'm going to have it draw me a scatter plot. But before I do that, so step 2, I'm going to say enter your data. Enter data, okay? And then step number 3, before I draw the scatter plot, I'm going to fix my window. Okay, before I have it graph it, I'm going to fix my window. And I'm going to say that your x's are going to go from, my smallest x was 3 and my largest x was 9. So let's go from 0 to 10 on the x, right? We would write it like this. X is going from 0 to 10. The y values, the smallest is 0.577 and the largest one is 1.462. So we could go, I'm just going to make it easy. I'm going to go from 0 to 2. Or we could go 0.5 to 1.5 if we wanted to zoom it in. Do we want to do that? Let's just go 0 to 2. We'll go 0 to 2. Okay, if we need to zoom in, we can. All right. And so I hit the window button. Okay, and I go to my minimum x. I want it to be 0. My maximum x, I want it to be 10. I want my minimum y to be 0, and I want my maximum y to be 2. Okay, and again, if I'm going too fast, please stop and pause and make sure that your screen looks like mine, okay? Now I'm gonna hit the graph button and it's gonna graph all of those dots for me. Oh shoot, if it's not graphing your dots, you may need to turn your stat plot on. So to do that, you would go second y equals and make sure that this button is on, right? If it says off, you'll hit enter and then you'll have to toggle it between on and off, okay? So if that's you and you don't see any dots, that's where that's at, okay? So there I have this function, and this is kind of pretty linear, like it's looking like a straight line there. So I'm not going to calculate the finite differences. We should have done that yesterday, I think. So that's just where you're subtracting to see if it looks like it's linear. We figured out how to do that yesterday, so I'm going to skip over that. And then the next thing that we want to do is we want to have the calculator find a model that best fits the data using the regression feature on the calculator. That's something that we don't know how to do, okay, yet, but we will. So step 4, I'm going to hit graph. Okay, yes, it's linear. Great. This part, this is how to do this part. Find the model that best fits the data, okay? So here we go. All of my data is still saved in my calculator, and I go back to that stat button. And rather than going stat edit, which is where I went to my lists before, I'm going to go stat, and I'm going to go over to calc, and I'm going to go down to where it says lin reg, and that means linear regression. I'm going to make a regression line that's linear, and it's going to be in the form of ax plus b. Okay, I want lin reg ax plus b. That's the option that I want to choose. Okay, so again, that was stat. Go over to calc and go down to lin reg. Okay, I'm going to write that information down. So stat, go over to calc, and go down to lin reg ax plus b. Some of you guys might have the option of like lin reg a or bx plus a. Oh, it's right down here, a plus bx. You don't want that one. I mean, it's gonna give you the same thing, but it's just gonna have your mx plus b flipped around. Okay, so we want lin reg ax plus b, and we're going to hit enter, and then it's going to give me some options. It's saying, do you want your x's to come from list 1 and your y's to come from list 2? Yes, that's what we want. So I'm going to go down to where it says calculate, and I'm going to hit enter, and it's giving me this junk, which like looks like a bunch of jumbo to me. All right, this is actually the model that we have, and so I'm going to start writing in y equals for my part C. And it says y equals ax plus b, where a is 0.148-ish, and b is 0.117 or 118. Let's go 3 decimal places. So I'm just going to plug these a and b into this equation here, and that's going to be my new equation. So a was 0.148. I'll say x plus 0.117. Okay, and that is my linear equation for this data. Okay, that's what the calculator's spitting out and telling me is the best fit line. Okay, it's kind of a mess because it's decimal things, but then the really nice thing is I could use this equation to then plug in different numbers that like I don't have in my table. Like I could choose 2 if I want the number, well, I can't have 2 number of sides, never mind. I could have like 12-sided figure, and that would tell me what the radius would need to be, because I can just plug that in for x, right? That's the really nice thing about making a model, all right? And then the last thing is talking about, part D is talking about the correlation coefficient, okay, and that's that R value, okay? So on here I have 2 values of R. I have an R squared and I have an R, okay? And my R is 0.9996, okay? And we said the closer that number is to 1 or -1, the better it is. So this is a good linear fit, okay? And when we looked at the scatter plot, you know, like it was a really good, nice linear function, okay? If you do not have that R squared and that R value, I'm going to show you right now how to get to that, okay? So if you have R squared and R on your calculator, you can just ignore the next 2 seconds, okay? So you will never have to do this again. I'll write it down off to the side, but you'll never have to do this again. So the first thing that you want to do is you want to go to catalog, which is second 0, okay? So I'm going to go second 0, which is catalog, okay? All right, so second 0 catalog, and you want to go all the way down to, it's all in alphabetical order, you want to go all the way down to where it says diagnostic on, okay? So there's diagnostic off and diagnostic on, and you hit enter, okay? And so I'm going to say step number 2, go down to diagnostic on, okay? You want to hit diagnostic on, so it goes to your main screen, and then you're going to hit enter again, and it's going to say done. You're going to go shut that off. Enter, and then it should say done, okay? And that's all you need to do. And then if you go back to your stat and go to calc and go to lin regression, it should calculate, and it should give you that R value if you did not already have that, okay? As soon as you've done it once, you should not have to do it again, unless you like reset your calculator for some reason. So there's that, okay? All right, and that will give you that R value. Okay, let's do one more problem and then we'll be done. Okay, we already talked about correlation and slope. So, you know, good correlation, bad correlation, no correlation, that type of thing. Okay, let's go up to this one. And this is where we're going to actually use our equation to do some calculations and things, okay? So I'm going to go second quit. I want to get out of here and I'm going to go back to my main screen so I have everything reset, okay? And it says the total number of farm workers in millions in selected years is shown in the following table. So it looks like I have 3 tables, but that's really just one table. They just didn't want to make it really long. So I have 1990 or 1900, 1920, 1930, 40, 50, 60, etc., right? Okay. And let's get that little recording thing off of there so you can see. Maybe I'll just move up. Okay. When I enter this data into my table in my calculator, I want to make it as easy as possible. So rather than typing in 1900 and 1920 and 1930, what I'm going to do is I'm just going to say that x equals 0 is year 1900, right? So all I have to do is type in the number 0 for that first one, okay? Then 1920 would be year 20. 1930 would be year 30, 1940 would be year 40, and that's going to save me a little bit of time because I don't have to type in the 19s every time, right? 1950 is year 50, this is 60, this is 70, this is 80. If I'm going too fast, please pause. Now we go to 85. They tried to trick us. They threw in an 85, and a 90, and a 94, okay? And then I have those values in there, all right? So this is going to take a little bit of time. I'm going to go into my stat, and I'm going to go edit again. Stat edit is where I enter my data in, okay? But I'm going to clear out my data that we just did. So I go up, clear, enter, and I go over, up, clear, enter. There we go. Now I'm ready to go. Okay, I'm going to type in 0 and 20 and 30 and 40. Look at that. See, I missed a 30. I got to go back up to 30. 30. Enter. There we go. Okay, 40. And now I have 50, enter, and 60, enter, and 70, enter, and 80, enter, 85. I'm being really annoying, but I have to talk out loud, otherwise I don't get it right. and 94. There we go. Okay, I've got them all on the X's. Now I go over to my list 2. And this is going to be where I really need to pay attention and take some time, because I have decimals in there, and even if I screw up one little piece, it will be wrong. Even just switching 2 numbers around or forgetting a number, it's going to be wrong. So 29.030, enter. Okay, 42 point. So take some time, pause the video if you need to, and type these into your calculator, and we will reconvene here in a second. Okay, I just got to typing all mine in, and I'm going to go back through again just to make sure I typed them all in correctly. 120.38, 117.49, 106.21, okay, 105.06, 79.802, 67.99, okay, 59.23, 51.742, 48.686, 42.206, and 29.03. Okay, all right, help each other if you need to. All right, use a linear regression to find an equation that models the data. All right, so I've entered my data in here. It doesn't actually have me graph it first, but if I try to hit graph, it's going to say like nothing, right? Well, why? Because our window is off. So if you want to see what this data looks like, they don't actually have me do it, but if you want to see what this data looks like, our x's need to be changed. Our smallest x is 0 and our largest x is 94. So I'm going to go 0 to maybe 100. You don't have to do this if you don't want to. My y's, my smallest y is 29, so let's go from 20 to 120, so let's go 130. Because we want to be a little bit outside that range. Okay, now if I graph them, there's my data. Kind of looks like a line. There's a little bit of slope in the middle of it, or like it slopes down a little bit, but it is a line, okay? And we'll see what linear equation it spits out. Okay, so to do this again, instead of going stat edit, we go stat over to calc and down to linreg, okay? And it's going to say, do you want list 1 and list 2? Yes, we do. And we're going to go to calculate. Enter. Okay, and there it spits out my equation. So, I timed out. My equation is y equals, and I have a is 1.011, no, 12 actually, 12, x plus 18.331. We'll go 3 decimal places, and that's my equation that it's spitting out. Okay, so I have a slope that's really close to 1 and a y-intercept that's 18 and some. All right, and then this is why we do this, is so that we can try to plug stuff in. So use the equation to estimate the number of farm workers in 1975. I don't have a 1975 in my data set, right? I could probably guess that it's somewhere between 79 and 105, right? But all we need to do to find that is to plug 75 into this equation, okay? And then I do the same thing for 2000. I would plug 2000 would end up being year 100. So I'm going to plug 75 in, and I'm going to plug 100 into my equation and get an answer here. So I'm going to go second quick. I'm going to go back to my main screen, and I'm going to type in 1.012 times 75 plus 18.331. Enter. And I get in 1975, I get that there was 94.231, and I think this is in millions maybe. That's what that is, which is right. Like that, we said that it was going to be a number between 79 and 105. That's probably true. Okay, in 2005 in 2000, if I type in 100, okay, I'm going to 1.012 times 100 plus 18.331. I'm going to type that in, and I get, this time I get 119.531 is my value that I get, okay? So that linear regression, finding that pattern or that line can really, really, really be useful when I go to, you know, estimate other values. Now, according to the model, when will the number of workers be 150 million? Let's see, should we plug some numbers in? I'm going to go back up to this equation. I'm going to start plugging numbers in, okay? Or I guess, okay, never mind. Let's do this. 150 million would be just plugging 150 in for y. Let's do that instead. So 150 equals 1.012 x plus 18.331. All I have to do is solve, right? And I don't, let's see, minus the 18.331, minus 18.331, and that will be, okay, I'm gonna go down, clear, 150 minus 18.331, and I get 131.669, and then I'm going to divide that by 1.012. Okay, divided by 1.012. Enter, and I get year 130 and change. So I'm going to say x equals 130.1, we'll say, okay? And that means 130 years past 1990, or 1900, okay? Whoop, where did I just go? I don't know. Yep, 130 years past 1900. So if I add 1900 to that, that would be the year 2030 is when or 2030, a little bit past 2030, because we have that 0.1. That will be the year that I will reach 150 million workers, okay? And then part C is align the best model for this data. If I go back to my LinReg, they're asking for, like, what was your R value? Okay, so if I write down my R value, R was, in this case, 0.969, which is not as good as what it was the last time we did this problem, but it's still pretty good. I would say pretty decent. I would say anything above like 0.95 is okay, or maybe 0.92. Okay, you're kind of getting out of the linear range, okay? But anything above 0.95 is pretty decent. 0.999 is really, really, really good, okay? So this is just kind of like using your own judgment as to what you think is a good value for R. In stats, if you guys take stats next year, we talk about like specifically what the R has to be in order to be deemed a good fit. But we don't talk about that in Trig. So I would say pretty decent, okay? We talked about this bottom part, so I give you lots of information today. Yeah, typing this into your calculator and learning how to run this beast is just kind of crazy. So I'll answer any questions you have on Monday, and there you go. Okay, homework is this stuff.